Good afternoon, students. Welcome back to chemistry class. Today we are going to study about quantum numbers and its significance. Significance of quantum numbers. About 4 quantum numbers, previous we learned clearly. Okay, you should study clearly the 4 quantum numbers. Then only you can understood how can write the electronic configuration. And about the shape of the orbital, we can understand after studying the quantum numbers. Okay, so quantum numbers very important. About 4 quantum numbers, study well. Can you have any doubt? You can ask me. Okay, it is very useful to further your studies. Okay, now we are going to study about the significance, quantum numbers and its significance. Okay, what are the 4 types of quantum numbers? Principal quantum numbers, azimuthal quantum numbers, magnetic quantum numbers and spin quantum numbers. Principal quantum numbers denoted by symbol n. Azimuthal quantum number denoted by symbol small l. Magnetic quantum number denoted by symbol small m l. Spin quantum number denoted by small m and s. Okay, ms. Very important. Principal quantum number tells about the shells. Okay, in an atom, nucleus present at the center and the electrons revolve around the nucleus in a circular path. These circular path we called as orbits or shells. Okay, about these shells we can study in principal quantum number. Okay, whatever shells are having K shell, L shell, M shell, N shell and so on. Okay, and azimuthal quantum number we can study about the shells are subdivided into subshells. Shells within the shells, subshells are having. About the subshells we can study in azimuthal quantum number. What our subshells are having? S subshell, P, D and F. Okay, each subshell having the L value, the principal quantum number N value, it is denoted by the K shell. N value 1 for K, N value 2 for L, N value 3 for M, N value 4 for N. Already we studied. In azimuthal quantum number small l, it indicates the subshell. Whatever subshells we studied is subshell P, D and F. When L is equal to 0 means S subshell, L is equal to 1 means P subshell, L is equal to 2 means D subshell and L is equal to 3 means F subshell. Okay, and the magnetic quantum number we study about the subshell. Okay, the principal quantum number studied about the shell, azimuthal quantum number studied about the subshell and magnetic quantum number studied about the subshell. Within the subshell having subshell we are called as orbitals. Okay, so orbital means the 3-dimensional space. One of the space 3-dimensional space, the probability of finding the electrons is maximum. That is called the orbital. Okay, about orbital we can study in magnetic quantum number. The orbital, orientation of orbital. What is the orientation of orbital in 3-dimensional space? That all about we can study in magnetic quantum number. Okay, and about spin quantum number. Spin quantum number, you know, every orbital, each orbital we can occupy only 2 electrons. Okay, so the spinning of electrons, the orientation of electrons we can study in spin quantum number. Okay, these are about the 4 quantum number, very important. Okay, so on the basis of these 4 quantum numbers. We can write now the significance of quantum numbers. Okay, so first listen carefully, take notes, very very important. First, K shell, whatever shells are having, totally 4 shells, whatever shells K, L, M and N. And what about the principal quantum number? What about the principal quantum number? It is denoted by the symbol small n. So K shell, what is the principal quantum number? 1. L shell, principal quantum number 2. N shell, principal quantum number n is equal to 3. N shell, n is equal to 4. Okay, n is equal to 1 means K shell, n is equal to 2 means L shell, n is equal to 3 means M shell, n is equal to 4 means N shell. Understood? And maximum number of electrons in a shell. Maximum number of electrons, how much number of electrons we can accommodate in K shell. That is in 2n square formula. 2 into 1 square is equal to 2. Okay. The second L shell, n is equal to 2. So 2 into 2 square is equal to 8. And M shell, 3, n is equal to 3. So 2 into 3 square is equal to 18. And final last n is equal to 4. So 2 into 4 square is equal to 32. This is all about the principal quantum number. And secondly, we can study about the azimuthal quantum number. Azimuthal quantum number, we know the integral value, we can start from 0 to n minus 1. 0 to n minus 1. Okay. So value of 0 you know S. Value of 1 means P. Value of 2 means D. Value of 3 means F. Okay. So here K shell, n value 1. So here azimuthal quantum number L, we can start from 0 to n minus 1. Here n value 1. So 1 minus 1 we can get 0. So azimuthal value, K shell value 0. Okay, 0 only. And L shell value, L shell, what is the orientation or what is the value of L here? N is equal to 2 means we can write 0 to n minus 1. Here n value 2, so we can write 2 minus 1 is equal to 1. 2 minus 1 is equal to 1. So we start from 0 to n minus 1. So 0 to 1. 0 and 1. And M value, third shell, the principal quantum number value 3. N value 3. So n value 3 minus 1, 2. So we can start from 0 to 2. 0, 1, 2. Okay. And about the N shell, principal quantum number value 4. Principal quantum number value 4. So azimuthal quantum number we can write 0 to n minus 1. So 4 minus 1, 3. So we can write 3, 0 to 3. 0, 1, 2, 3. Understood? So azimuthal quantum, according to azimuthal quantum number, small l, that indicates the subshell. So K shell, only one subshell, 0. 0 means S orbital. And L shell, there are 2 L value, 0 and 1. 0 means S shell and 1 means P shell. Okay. And M shell, there are 3 subshells, 0, 1, 2. 0 means S shell, S subshell, 1 means P subshell, 2 means D subshell. And finally N shell, there are 4 subshells, 0, 1, 2, 3. 0 means S subshell, 1 means P subshell, 2 means D subshell, F means 4 means F subshell, 3 means F subshell. Okay. Understood? These are about azimuthal quantum number. And maximum number of electrons in a orbital. Maximum number of electrons in a orbital. Azimuthal quantum number, denoted by symbol L. the maximum number of electrons in the orbital. Okay, here s orbital, we can write the using the formula 2 into 2l plus 1. 2 into 2l plus 1. So 2 into L value here for 0. So 2 into L value 0 plus 1. We get 2 into 0. 0 plus 1, 1. So 2 into 1, 2. Okay. And here also 0. L value 0. So we get 2. And here L value 1. So we can write 2 into L value. For L value we can write 1. 1 plus 1. We get 2 into 1, 2. 2 plus 1, 3. 3 into 2, 6. 3 2s are 6. Okay. And here also 0. 0 means maximum number of electron 2 using this formula. And 1 means maximum number of electron 6 using this formula. 2 means 2 into L value 2 plus 1 is equal to 10. 2 into 2, 4. 4 plus 1, 5. 5 into 2, 10. Okay. And about the fourth shell divided into 4 subshell 0, 1, 2, 3. 0 means S subshell, P, D and F. So here 0 means how much electron we can occupy in S orbital? 2 electron. Okay. According to this formula, 2 electron. And P orbital 6 electron. D orbital 10 electron and F orbital maximum 14 electron we can accommodate. Okay. And next about the magnetic quantum number. Magnetic quantum number, it explains about the orientation of orbitals. Okay. So principal quantum number explain about the shells. Azimuthal quantum number explain about the subshell, and magnetic quantum number explain about the subshell. Subshell means orbital. Orbital means the three-dimensional region or three-dimensional space in which the maximum probability of finding electron is maximum. That is called the orbital. About the orientation of orbital we can study in magnetic quantum number. About the orientation orbital we can study in magnetic quantum number. So how much orbital, how we identify how much orbital? Here we are using one of the formula 2l plus 1. Yesterday we studied clearly. So magnetic quantum number for L value 0 means 2l plus 1. 2 into L value 0 plus 1 we get 1. Okay. So for S orbital, for 0 means S orbital. S orbital, how much orbitals are there? Only 1 orbital. And when L is equal to 2, L is equal to 2. L is equal to 2 means 2 into 2 plus 2. 2 into 2 plus 1. 2 into 2 plus 1, totally 5 orbitals. So P orbital, L is equal to 1. L is equal to 1 means 2 into 1 plus 1 is equal to 3. So P orbital, L is equal to 1 means P orbital. P orbital, maximum number of electrons. We can, how much orbitals are there? 3 orbitals are there. Okay. And L is equal to 2. L is equal to 2 means D subshell. D subshell, how much orbitals are there? We are using 2L plus 1 here. L is equal to 2. 2 into 2 plus 1, totally 5 orbitals. And for L is equal to 3. L is equal to 3 means F orbital. F subshell, how much orbitals are there in F subshell? 2L plus 1 is equal to 2 into 3 plus 1. We get totally 7 orbitals. These are about the orbitals. Okay. So maximum number of orbitals, this is orbital, and then magnetic quantum number we can study the orientation of orbitals, different possible orientation of orbital. Okay, here the how we can write the orientation. Orientation we can write. Orientation we can write. We can start from minus L to plus L through 0. Minus L to plus L through 0. Okay, minus L to plus L through 0. Here L value 0. L value 0. So magnetic, the different possible orientation of orbital here 0. Okay, and also K L shell. How much subshells are there? 2 subshell, S subshell and P subshell. Okay, P subshell. So S subshell, the orientation 0, and P subshell, L is equal to 1. L is equal to 1. So the magnetic quantum number orientation will you write? 1 means the minus L2 plus L through 0. So L is equal to 1 means minus L, 0 and minus 1, 0 and plus 1. Okay, and M shell, there are 3 orbitals there. 0, 1, 2. 0 means S orbital, 1 means P orbital, 2 means D orbital. Okay, so orientation of S orbital, 0 means 0, orientation 0. 1 means minus 1, 0 plus 1, and 2 means what is the orientation? We can write from minus L to plus L through 0. Okay, so L value 2, so we can write minus 2, minus 1, 0, plus 1, plus 2. Okay, and fourth shell, N shell. N shell, there are 4 subshells are there. 4 orbitals or 4 subshells are there. S orbital, P orbital, D orbital and F orbital. Okay, and what are the orientation? S orbital, only 1 orbital there. P orbital, 3 orbital. D orbital maximum how much orbital? D orbital 5 orbitals are there, and F orbital 7 orbitals are there. Okay, what are the orientation? 0 means 0, 1 means minus 1, 0 plus 1, 2 means minus 2, minus 1, 0 plus 1 plus 2, and F orbital, how will you write? We can write the orientation from minus L2 plus L through 0. Okay, so L value here 3, so we can write minus 3, minus 2, minus 1, 0, 1, plus 1, plus 2, plus 3. Totally 7 orientation. 7 orbitals, so 7 orientation here. Okay, understood? I hope all of you understood clearly. And then, how will you write the designation of orbitals in a given shell? Here, S orbitals, so much S orbitals are there, and so much P orbitals are there, D orbitals are there, Okay, so how will you write how will you give the designation of this orbital? Okay, so 0 here, 0 means it indicates L. As L equal to 0 means S orbital, we know. L is equal to 0 means S orbital. Okay, so S orbital, we can write S. Here also L is equal to 0, so we can write S orbital. And here L is equal to 1. L is equal to 1 means P orbital. P orbital, we can write how much orbital, how much orientation here? P orbital, 3 orientation, minus 1, 0, plus 1. Okay, so how will you write the orientation here? For minus 1, Px. For 0, Py. For plus 1, Pz. Okay, so designation of the P orbital, Px, Py, Pz. Okay, and here the 0 means S orbital, 1 means P orbital. P orbital, totally 3 orientation, Px, Py and Pz. Px, Py, Pz. And then 2 means which orbital? L value 2 means D orbital. L value 2 means D orbital. D orbital, how will you write the orientation? How many orientations are there? 1, 2, 3, 4, 5 orientation. Okay. 5 in D orbital, totally 5 orbitals are there. How will you write the orientation? D orbital, dxy, dyz, dxz, dx square minus y square, and d is z square. Okay, these are the orientation of d orbital. Okay, dxy, dyz, dxz, dx square minus y square, and d is z square. Understood? And the fourth also, n value 0 means s orbital, only one orientation s orbital, and 1 means p orbital. There are 3 orientation, px, py, pz, and 2 for d orbital. L is equal to 2 means there is d orbital. D means how many orientation? 5 orientation. What are the 5 orientation? dxy, dyz, dxz, dx square minus y square, and d is z square. And then the L is equal to 3 means f orbital. F orbital totally how much orientation? 7 orientation. 7, whatever the 7 orientation. F xz, f x y z, f x z square, f y z square, f z cube, f z x square minus y square, f x square minus 3y square, f y 3x square minus y square. Okay, these are the 7 orientations for the f orbital. What are the 7 orientation? fx yz, fx z square, fy z square, f z cube, f z x square minus y square, f x square minus 3y square, f y 3x square minus y square. These are the 7 orientation for f orbital. Okay, understood? Then we are writing only the orientation, and there are several s orbitals there. There are and several p orbitals. 1, 2, 3, 4 p orbitals there, and 2 d orbitals there. How will you give the number? Okay, how will you give the number? First one, s orbital. S orbital, it is placed in first shell. Okay, first S orbital, it is placed in K shell. K shell means quantum number, principal quantum number 1. Okay, so designation of s orbital oneness. Okay, and second, L shell. L shell divided into 3 orbitals. What are the 3 orbitals? 2 orbitals, s orbital and p orbital. S orbital and p orbital. Okay, so s orbital, the principal quantum number 2, so we can write 2s. Okay, here p orbital, principal quantum number here 2, so we can write 2px, 2px, 2py, 2pz. Okay, and then the third M shell, third shell. So third shell, how many subshells are having? 3 subshell. D, S, P, and D subshell. S subshell, only 1 orientation, and P 3 orientation, and D 5 orientation. Okay, how will you give the number? Principal quantum number for M shell 3. Okay, N is equal to 3. So 3S, 3P, X, 3PY, 3PZ, and 3DXY, 3DXZ, 3DYZ, 3D x square minus y square, and 3D z square. Okay, understood? And then last, finally, fourth, N shell. N shell, the quantum number 4. Principal quantum number 4, n is equal to 4. So we can write 4s, 4s, 4px, 4py, 4pz, 4 and then d orbital, 5 orientation, 4dxy, 4dxz, 4dyz, 4dx square minus y square and 4dz square. Okay, and finally f orbital totally 7 orientations. Okay, so principal quantum number n is equal to 4. We can write the 4fxyz, 4fxz square, 4fyz square, 4fz cube, 4fz x square minus y square, 4fx into x square minus 3y square, 4fy into 3x square minus y square. Okay, wow. These are the designation of orbitals in a given shell. Okay, very important, very important. You should study all the designation, study clearly. Okay, if you have not having book, if you're not having book, you should write now. Okay, students should write, should study and take written practice more and more time. Okay, and then send me through my WhatsApp number. Okay, thank you all of you.